Hello everyone, it's great to be here among so many horse and dog enthusiasts. The title of this talk is Where Horse Meets Hound, the Diet, Microbiome, Emotions and Behaviour Connection. For me, it's quite natural to talk about horses and dogs at the same time. Both are such very different animals, but of course, most people who own horses actually have dogs too. So here's a summary of what I'm going to be talking about today. Emotion states and mood states, the importance of body language, personality, which matters also as well, the Lallemand PetWAG tool, and finally, calming supplements and how they work. So in 1969, Paul Ekman did a study of many different cultures all around the world, and he identified 6 basic different emotional types, and he added a seventh one, content, a bit later on. Now, I'm sure if you look at these faces, you can identify all of these emotional states, this goes back to your early childhood because it's something that we learn very, very early on, and it is actually innate within our species. So what are emotions? Basically, the psychological definition for them is impulses to act. They are stimuli which invoke specific output responses, behavioral responses, neurophysiological responses, such as release of neurotransmitters, hormones, such as cortisol, adrenaline, and so on. And also they create or induce subjective feeling states. These are the things that we talk about as emotions of having feelings. Now, I need to put this in here because many scientists don't like the idea of talking about subjective feelings in animals. I'm sure that you, like I do, feel that animals do experience very similar emotional states as we do. But I put this anthropomorphism alert in here just to cover ourselves so we don't get criticized. And what about mood states? Mood states are very similar to emotion states, but the big difference is that mood states become cut off from the external stimuli which produce them in the first place. So emotion states are direct reactions to external stimuli coming in. Mood states then get cut off, and then they are the states that the animal learned from previous external states or external stimuli, and they then become internalized. And this is what can lead to chronic anxiety disorders, depression, and chronic mood disorders like that. So here's something that you can try at home. If you draw a chart like this on a piece of paper, the top left quadrant are emotional arousal, or at least emotions that are highly charged, they're highly negative, high arousal level. On the bottom left quadrant, they're still aversive, they're still negative, but they are fairly low arousal level. So things like being depressed, unable to work, feeling sad, feeling dejected, unable to enjoy some pleasant experiences. And then we have the positive emotions on the right-hand side. For example, you can be hugely excited at winning something like the lottery, and you can be absolutely sort of ecstatic about that, graded down to just being happy, being content, being out with friends, enjoying yourself, and then at the end of the day, feeling relaxed and calm and falling asleep. So there's a whole range between positive and negative, high arousal and low arousal. And what you can do if you have a chart like this is to plot your emotional states over the course of a day. And if you do this over several days and then wait for maybe after a week and then draw a line around all the crosses that you've plotted on that chart, you can get something like this. And what this is basically a fairly objective representation of what your mood state is based on all those emotional states that you've experienced over that period of time. So the key point here is that a mood state is basically the average of all your emotional states over a given period of time. And if we did exactly the same thing for somebody completely different, what they might do is get a chart that looks something like this. So you can see the crosses seem to be appearing much more on the left-hand side of the chart here. And if we then average those up, we're going to get something that might look like this. And as you can see, the resulting mood state from all those emotional states has shifted over to the left-hand side of the chart. And so what we have now is a fairly clear indication, having averaged up all those different emotional states, of the difference between something which is a fairly good emotional state, as you can see in the left-hand diagram here, and something which actually is much more of a poor mood state on the right-hand side of the diagram. So what about body language in dogs? I talked about body language in people right at the beginning, about being able to read emotional states from human faces. And we do very much the same thing when we look at dogs and we judge how they might be feeling inside. So from this diagram here, you can see fairly clearly that up the top, there's some happy dogs, waggy tail, open mouth, tongue out, a dog wanting to play, a dog standing there alert with a smiley face. And down the bottom, we've got much more negative emotional states reflected, with dogs slinking off, dog looking with wide eyes, a dog perhaps growling, as you can see down the bottom right-hand side, and a dog lifting a paw in the air. So there's a clear difference that we can tell from simply dogs' behaviour as to whether their emotional states might be positive or might be negative. The dog that's rolling over on her back, you can see up in the top left, the right-hand corner, the top right-hand corner, is what we would call an ambiguous emotional state. We're not quite sure whether she'd be happy or whether perhaps she's a little bit nervous and doesn't want to be approached. So, body language does give us quite a useful window into what dogs' emotional states might be. Now, this is much more difficult with horses. Horses are much more difficult to read, unless, of course, they're showing fairly extreme emotional states, such as rearing up and neighing and perhaps trying to kick you. And emotional states might be expressed in that sort of form. But what's happened over the last decade or so is that scientists have been working very hard to try and work out ways of reading horses' emotional states from their body language in much more objective ways. Now, I'm pointing you here to a very useful scientific resource. That's Equifax, the Equine Facial Action Coding System. This is a free resource. You can download it. You can use it as you like. There are lots of really, really useful videos, clips, and photographs in this. And what they do is they give you a set of objective ways of measuring potential horse emotional states. Now, one of the things that these have been used for extensively is measuring pain states in horses. Pain is an incredibly difficult thing to measure in animals that don't verbalize and can't tell you how they feel. So what I'm going to do now is show you 3 video clips of the most reliable indicators of pain in horses. The first one here is called AU17. This is the chin raiser, and it also changes the appearance of the upper lip, as you'll see in this video clip. You can see here, the chin goes up, if you look carefully, and there it is. But as I say, you can download all of these video clips from the resource and look at them very closely yourself, play them in slow motion and so on. This is the second video clip I'm going to show you. This is AD38, the nostril dilator. Just to be clear, the code AD38 and so on are basically the code numbers that have been given to all the different kinds of facial expressions that you can see in horses. There are a whole array of them, about 20 or 30 of them. So this is the nostril dilator here. So in slow motion, you can see the nostrils flaring up. And there they go. And finally, this is the last one. This is the half blink. Beautifully demonstrated there in slow motion. So as I say, there are many more of these. And just for your kind of to know, if you like, there is also another set of resources that are called the horse grimace scale. And these are basically based on the human newborn baby grimace scale that was developed for newborn babies who can't verbalize whether they're feeling uncomfortable or pain or not. So a similar set have been developed for cats and for horses for use in trying to assess pain in these animals. So I encourage you to go and look these resources up as well and download them. Again, they're free, they're in the public domain. So really, really useful to have in your kind of library of information. So what about pain in dogs? I'm not going to say anything about dogs here simply because of constraints of time, but there have been many, many studies carried out over many years. And I point you to this really useful paper here, Pain and Problem Behavior in Cats and Dogs. This was led by Daniel Mills at the University of Lincoln, and it's pulling together all the research and all the resources that have been done in trying to identify pain in dogs and cats, which actually is quite a serious welfare problem in this species. Right, what about personality? I said that personality is important too. There have been many studies investigating personality in dogs, and many of these studies have been really based on the famous big 5 personality traits in humans: neuroticism, agreeableness, conscientiousness, extroversion, and openness. Now, what I've spent time doing over the last 2 or 3 years is bringing all the information from all these different canine studies into one place and consolidate them down to something much more simple. And from what I've been able to find, I found basically 2 broad categories of personality types in dogs. And those are confident and sociable, up here at the top. And these are dogs that are friendly, outgoing. They always like to be out, greeting people, out on walks, playing, and so on. So that's confident and sociable. And then there's the shy and not sociable. So these dogs are generally dogs that are perhaps less interested in going to meet strange people, strange dogs, perhaps a little more reserved. They like to spend time around you rather than around other dogs and people when they're out on their walks. And I'm sure you're familiar with both of these kind of personality types in dogs. And what we can then do is split each of those 2 broad groups into 2 different subgroups labeled A, B, C, and D, as you can see on the screen here. So with our confident and sociable dogs, we can identify dogs that enjoy playing. They like to chase balls and that kind of thing, so your Labrador types. And then the other dogs which are much more sociable about being around other people and around other dogs. They're not so interested in playing games and so on. So these kinds of dogs, type B, tend to be the gentle giants. Then within the subgroups of the shy and not sociable type dogs, these are dogs that perhaps really aren't fazed by noisy fireworks and strange environments they're not familiar with. And then within this group, we also have the dogs that really don't like loud noises. They're much more timid. They're much more the kinds of dogs that are going to be quite anxious. So 4 nice categories that we can use, and I'll come back to these a bit later. Now, can we apply these same kind of ideas for horses? Well, this is a kind of ongoing project, but I think we probably can. I put some ideas in here based on my work with dogs, and I have to tell you that this is currently a work in progress, so I can't give you a definitive answer at the moment, but I will refer you to a few papers here which you can go and look up yourself if it's an avenue of interest that you might want to follow up on. So, right, I've been working very closely with our friends at Lennimand in developing a range of easy-to-use tools to help folks like you to measure and monitor the welfare in your dogs, and perhaps a little bit later on in horses too. And what we've come up with is this tool called PetWAG, which stands for the Pet Wellbeing Assessment Guide. So what I'm going to show you now is a short video clip which tells you basically how this works.
Dogs live complex emotional lives just like we do, and looking after their emotional well-being is key to ensure their overall well-being. Follow our 4-step guide to take control and measure your dog's emotional well-being. Dogs have different personal profiles. As first step, choose the category which best fits your dog. As second step, learn to identify your dog's body language. Dogs express how they are feeling through many different and subtle changes in facial expression and body posture. Depending on the dog's personal profile, the same posture may have different meanings. Step 3. Use the wheel on the brochure. It'll help you estimate your dog's emotional state. Record your 3 daily scores in the calendars inside the folder. At the end of each week, calculate the total score. After 4 weeks, you have enough information to calculate your dog's rolling average mood state, known as RAMS. Step 4. Compare your dog's results with the RAMS score to measure your dog's overall emotional well-being. Consult the PetWAG brochure to find practical tips and natural microbial solutions that will help you trend green.
Right, so what PetWAG does is that it brings together everything I've talked about so far, emotions and mood states, body language, personality, and so on, into one easy-to-use tool. So just to summarize what you can do with PetWAG tool, you can measure daily emotional states in your dogs in order to assess their mood states. This is based on your dog's body language, as I talked about, and scores for emotional states fall into 3 broad categories, as you can see here. Note the color coding. We've got clearly positive emotional postures. So this is body language up the top here in green. And what we do when we see our dogs perform these kind of behaviors, when we do our spot check of checking their emotional states during the day, is we score that with a +1. Then down the bottom, we've got clearly negative emotional postures. These are postures that are showing some kind of negative emotional states. That we talked about when I showed you the body language, and we score these as -1. And then we've got these other types of behaviors that we'll often see, which are ambiguous, such as the rolling over on the back, the lying down sleeping, and maybe just staring without showing much expression in the face. So they're ambiguous because we're not sure whether they're positive or negative. And what we do is we score them with a 0. And the reason we do that is because when we score them on a chart like this, as you saw in the video. This is a weekly calendar, and we simply use a pen or pencil and put a cross into whether they're +1, positive, -2, negative, or 0, which is ambiguous. And at the end of that time, we can then give the animal a score. And the reason we do that is because our goal is to make sure that our pet is always trending green. We don't expect animals, just like we don't expect people, to be happy and jolly and have positive emotional states all the time, because life isn't like that. Life is complicated, life is full of stressors. But what we do want over time is for our animals and ourselves as well, of course, is to have primarily kind of positive emotional states on average. And so this is what we mean by trending green. And what's really useful about this tool is that we can also apply it to our own mental well-being. And I think if we're checking in on our dogs and assessing our dogs' basic emotional well-being, it also gives us time to check in on our own work-life balance. Often work does tend to get, take over, particularly after the pandemic. And it just gives us time to kind of stop and pause and think about our own mental health as well. So are we going to develop a HorseWAG tool as well? Well, maybe that might be something that's in the offing, but I'll leave that as a kind of open question for some kind of project in the future. So what about calming supplements? And particularly how we might be able to use them when emotions and mood states go wrong. What I could do is ask you whether you use calming supplements yourself, if I had a live audience, whether you've recommended or used them in your horses and in your dogs. And I suspect the answer is probably yes for both, because they are really popular. And I know myself in my own behavior work is that many owners have tried calming supplements in both their horses and dogs. Sometimes they've worked, sometimes they haven't, but they are certainly a popular thing to use than simply to buy over the counter. So no matter what supplements you use, or no matter what supplements you've tried to use or recommended in the past, they basically fall into 5 broad categories. And you're already familiar with all of these, in fact. We've got GABA, we've got glutamate, We've got your favorite serotonin, dopamine, and of course there's also noradrenaline and acetylcholine and others, of course. And also, most importantly, we've also got the microbiome. Quite a few supplements in horses and in dogs too also claim that they use prebiotics and probiotics as part of the formulation of those supplements. So how do they work? How do they change emotional states? If you have a look at the diagram on the right-hand side, this is a diagram of a tiny piece of brain, less than the size of a grain of salt, of about 613 neurons. How many synapses in there really is probably uncountable, and you can see how complicated it is. Now, the diagram on the left-hand side is basically a schematic I've drawn of just 14 neurons and about 26 synapses. And you can see in this diagram all the neurotransmitters I've talked about. Here's glutamate, the red ones are the GABA ones, and we've got serotonin, we've got noradrenaline, dopamine, and so on in here as well. And my key point is that if a supplement was to fire just one synapse here, this could affect, in this tiny circuit all by itself, this could affect the animal in over 1 million different ways, i.e. in terms of its emotional state. If it affected one kind of pathway, that could actually perhaps calm the animal and be quite useful. But if it affected another one of those pathways, it might actually make matters worse. And this might explain why some supplements can sometimes help animals and some supplements, sometimes they don't, or sometimes they make no difference at all. Now, this is really complicated, and that's okay. You're not supposed to understand it. And to be honest, even neuroscientists don't really understand how this works. Neither do psychiatrists understand it either in prescribing for people. So it can be very kind of hit and miss. That's just the nature of dealing with emotional states and mood states using pharmacology. It's still a very early science, and we still have much to learn about it. So kind of summing up, what we do need to understand is this. Our ultimate goal as responsible pet owners is to ensure that our dogs and horses maintain happy and healthy mood states over time. And what you can see at the top, these dials represent different arousal levels and different activities in all the different neurotransmitter systems, dopamine levels, serotonin, noradrenaline, acetylcholine, and so on and so forth. And this dial over here shows the average of all these different systems. And what you can see with the wide swing of these dials is that this represents a really poor mood state for this particular animal. Down the bottom, you can see the dials are much less wide in their scope, and they're much more controlled within that middle green range. And so this really represents a good mood state. And you can see in these photographs over here on the left-hand side, animals that are perhaps clearly stressed and represent animals that could have poor mood states, and on the contrary, other ones that are really quite excited and have much happier mood states, and clearly their welfare would be better. So just to sum up and to reiterate one other point here, I talked a little bit about chronic pain in horses and also mentioned chronic pain in dogs. This is a huge problem which is often left undiagnosed and unrecognized. And in relation to poor mood states and good mood states, chronic pain, chronic gut problems, pancreatitis, chronic fear, anxiety, loneliness, all these things contribute to the overall mix of whether one is going to have a good mood state or poor mood state, and feeds into what we're measuring in our pets in the PetWAG tool. So what about L-tryptophan in the diet? One of the things that, at least the claim that's made about L-tryptophan, is that somehow animals that are in a state of stress, anxiety, have low serotonin in their systems. Now, I kind of dispute this claim. I think it's oversimplistic. And so I'm going to give you a much more plausible and much more scientific explanation of how they might work. And it ties very much in with the microbiome of the animal too. So just a very quick evolutionary lesson here. Serotonin first appeared in living things, in plants, in fact, long before animals appeared on the planet. Then about 600 million years ago, it emerged in animals as well. And these were animals, basically sponges that lived at the bottom of the sea. They didn't move. These animals didn't have brains, but they did have guts. And what they did is they recruited tryptophan, the amino acid, to produce serotonin, which then became an important neurotransmitter in the guts of these animals. And I reiterate, these animals didn't have brains. About 400 million years ago, so after these sponges emerged, we then got vertebrates, which then, of course, had brains. And the vertebrates developed a second serotonin system, which was in the brain. Now, these two serotonin systems, the gut-brain serotonin system and the brain serotonin system, are completely separate. And then, of course, now 60 million years ago, we had mammals evolve, and that brings us where we are today. So you can see serotonin isn't something which is recent. It's something that's been around in the animal kingdom for millions and millions of years. And what we have as mammals is something which is really quite sophisticated and part of the brain, the complicated brain neurotransmitter system that I talked about earlier. So let's kind of break this down and see what we mean about the gut-brain axis. So here I'm showing you an image of the enteric nervous system. So this is the first one to evolve. This is the one that controls the gut. And it has many functions. It basically controls gut motility, appetite, energy homeostasis, and importantly, it also communicates with the brain via the vagus nerve and via hormones which it secretes into the blood. Then we've got the central nervous system. This is the second serotonin system that first appeared in vertebrates. And again, this has bidirectional communication with the gut nervous system via the vagus nerve. But this time, there's no hormonal interaction from the brain to the enteric nervous system. There's only hormonal interaction via the bloodstream from the enteric nervous system into the central nervous system. And then we have the gut microbiome. This developed sometime during evolution. We're not quite sure when, but this is hugely important because what it does is also make a contribution to the control of many metabolic and also emotional mechanisms in partnership with the brain. So here we have why we call this the gut-brain axis. It's because of the interaction between the microbiome, the enteric nervous system, and the central nervous system as well. Now, one important thing about the microbiome is that there are a few bacteria within the microbiome that can produce their own tryptophan, but there aren't very many. Most of them don't. And the reason tryptophan is an important supplement in the diet is not only because it makes or is the precursor for serotonin itself, but also many of the bacteria in the gut microbiome also use tryptophan to make many bioactive compounds which themselves are responsible for controlling homeostasis, the gut-brain barrier, immune system, and also stabilizing and maintaining homeostasis of emotional states in the brain. So this is really what we mean by the gut-brain axis. So from my point of view, when we talk about tryptophan in the diet, my argument is that in actual fact, it doesn't go up into the brain and get turned into serotonin and work there. Its job is to feed some of these bacteria in the gut to make byproducts of tryptophan, which then interact with the brain indirectly to stabilize the mood and emotion states that way. And of course, this is one of the reasons that we use prebiotics and probiotics in animals, because it's another way of simply putting in the right kind of bacteria that are then going to do this transformation of tryptophan into useful products and therefore stabilize the central nervous system that way through these indirect pathways. And finally, one of the other most important systems of this gut-brain axis is the immune system, which is shown in red here. Because the gut is basically a long tube that passes right the way through the animal, from the mouth through to the anus, it basically is open to the environment and therefore open to all sorts of toxins and infections and everything else. So the role of the immune system in the gut is hugely important. And an awful lot of the diet's tryptophan goes into this immune system as well as part of the body's defenses. And I bring you back to this diagram here with all these components of the gut-brain axis, the central nervous system, the enteric nervous system, the important microbiome, and also the immune system. All these can contribute to this idea of this vicious cycle of chronic pain, chronic gut problems, pancreatitis, fear, anxiety, loneliness, and so on. So I keep coming back to this diagram because I can't emphasize how important it is that this lies at the root of why we're always talking about balanced diets and the external welfare of animals and so on and so forth. And finally, I'm just going to make a quick note or make a quick comment about dietary tryptophan here. We know that tryptophan is an essential amino acid. We know that tryptophan comes from protein sources in the diet exclusively, from nowhere else. And this slide just gives you a breakdown of where that tryptophan goes. The thing I want you to note here is that 93%, i.e. most of it, actually goes into the immune system. That's how important the immune system is. A tiny, tiny bit goes into making serotonin in the brain. 4 times as much goes into the microbiome to be converted into the other bioactive compounds that I talked about earlier. And a little bit of it, 2%, goes into the serotonin system in the gut. So as you can see, the minority of tryptophan actually goes up into the brain to make serotonin. The role of tryptophan is much more important in the gut-brain axis through all these other pathways here. So what it comes down to, it's all a question of balance. The immune system, the serotonin system, the gut-brain axis. And it's all about maintaining, as you can see in this animation here, homeostasis and balance between all these systems together. So what commonly affects the microbiome in horses? Here are a couple of studies which basically highlight 2 key factors. One is the diet, so what the horse eats can actually affect the microbiome, and the other is transportation. There are many others, but these are the ones I'm going to include here in this presentation. So let's just have a look at the diet. This is an interesting study that was done a couple of years ago on behavioral. They're basically horses that were basically normal, behaviorally healthy. And what the researchers did is that they started by feeding these horses a really high fiber diet. So this was 100% good quality hay. And then over time, they gradually reduced the amount of fiber and increased the amount of starch in that diet to a ratio of about 56% hay to 44% barley. And what they noticed is this caused a shift in the microbiome, which one might expect. But what was really interesting and perhaps unexpected about this study is that as the amount of fiber went down, the levels of anxiety in these horses started to go up. And as you can see on this chart here, clearly a clear correlation between a high fiber diet and low anxiety levels, and a low fiber diet and high anxiety levels. And this study has been repeated using many different kind of scenarios. And I think it's one of those things that really highlight the importance of what a horse actually eats to how that might affect its emotional state. And this is a study on the effect of transport on the stress levels in horses. What this study shows, a bit like the previous study I've just shown, is that the quality of the prebiotic, which in effect is quality kinds of fiber, high quality fiber, what the effect of prebiotic is on the diet on stress in horses. And what this study did is it used a probiotic, in this case a yeast Saccharomyces cerevisiae, which in effect worked by increasing the level of quality prebiotic in the gut, because the cell wall of this bacteria is also a quality fiber source. And by increasing the prebiotic in the gut, like the previous study, it also protected or immunized these horses against travel stress. And what if we look at dogs? What kind of things affect the microbiome of dogs? I'm not going to talk at any length about this. There are plenty of studies that are out there if you want to go and look them up yourself. But I found this study actually quite scary, because what they found is that an abrupt change in diet caused a rapid change in the microbiome of dogs, which occurred in something like about 6 to 10 days. So this is really similar to that study that I showed you on horses, where changing the diet caused a rapid change in the composition of the microbiome. So the question is, does changing the dog's diet and therefore changing the microbiome also have an effect on anxiety and stress? Well, the answer, or at least the short answer to that, is yes, it does. And this has been demonstrated in a study that I'll show you here, which shows the effects of the microbiome on whether or not animals are going to develop canine cognitive disorder later on in life. And so what this research showed is there's a clear correlation between changes in the microbiome, the quality of the microbiome, and the risk of dogs developing doggy dementia later on in life. And again, this is a study in the public domain, so you can go and look it up yourself and read it through in more detail. Summing up, I explored emotional states in dogs and horses, and I carefully avoided falling into the anthropomorphism trap. I claimed that basic emotions are very similar to those experienced by people. I then showed you that mood states turn out to reflect a range of emotional states, good and bad, an animal can experience over time. And that we can measure these animals' mood states using the PetWAG mood state tool. I then showed you how we can assess emotional states in both dogs and horses by studying their body language. It's much harder in horses than it is in dogs, and I showed you how this can be done by analysing facial expressions in horses. I then talked about canine personality and how I've simplified this into two broad categories, confident and sociable, and shy and not sociable. And I'm looking at the moment as whether or not this can be applied to horses too. I talked about pain in both horses and dogs and referred you to several online academic resources that highlight its importance in the welfare of these magnificent animals. And then finally, I talked about the use of supplements, how they work, and how they can help dogs and horses cope with emotional distress. I talked about a number of studies that show the importance of diet and the gut microbiome and how we can use probiotic, prebiotic, and postbiotic supplements in horses and dogs. So thank you very much for listening, and that's all I have to say.